Greetings, ladies and gentlemen. In this math guide video, you're going to learn how to teach vector inclined plane problems. So first we're going to talk about the standards and practices that will be addressed. Then we're going to talk about several questions that will lead to student engagement. We're going to get into the actual trigonometry of inclined planes. And then we're going to talk about how MATHguide's Quizmaster can be used to assess students and why this assessment is important for teachers and for student feedback. Let's get started. This is MATHguide.com, and my name is Mark Karadimos. So the standard that will be addressed will be to solve problems that can be represented by vectors, and the practice would be model with mathematics. Well, the first question that I would use to provide some engagement for students is I would ask them, why is it right now that you are not crashing through your chair? I would like students to think about that question. I'd like to give them some time, maybe reflect on it, talk to a partner about it, and then as a class we would discuss it. Well, what students would eventually be led to understand is that there are forces at play, and these forces are kind of important for understanding the inclined plane and just forces in general. So it's true that when you sit on a chair, there's some force, a downward force. We call that force the weight of the person on the chair. And the reason why the chair doesn't allow the person to crash right through it is because the chair has some stability of its own, and it provides a force back. So whatever the force is that's going down, let's say it's 120 pounds of force, the chair provides 120 pounds of force right back. So therefore, no one does go crashing through. So there's this equal but opposite reaction, and that internal stability of the chair is kind of important to understand the inclined plane, because that's going to come up in a moment. So another question that I would ask students to determine their readiness for the next part of the inclined plane mathematics is to ask them this question. So in which scenario would it be harder to push a car up a hill? Would it be a 2-degree angle, a 5-degree angle, or an 8-degree angle? And I let them mull this question over, and then we would discuss it. Here's another question for students. I would ask, as the incline of the hill becomes more steep, would it be easier or harder to push a car up that hill? So at this point of the lesson, students should have an understanding that as the incline of the hill increases, it becomes harder to move a car up that hill. So the next part of the process of this lesson is trying to help students choose a trigonometric function that matches that mathematics. So of the two trigonometric functions, there's cosine and there's sine. So what you want to do is ask students which of those two functions would be better for modeling this situation. So if students have an understanding of what the functions look like, if they have an idea of what the graphs of those functions look like, they're going to be able to give you a pretty decent answer on that. If students understand the unit circle, they should have an understanding of what happens as that angle increases from 0 to 90 degrees or from 0 to pi over 2. So if students have an understanding of either graphs or the unit circle, they should be able to come to the conclusion, at least through the discussion of an entire class, that the sine function is the best choice for modeling purposes. Okay, and the reason why I would suggest that students be asked that question is because oftentimes students forget the mathematics and they forget what's about to come next, which is the explanation of the actual trigonometry behind the inclined plane. And so you could reason through this almost qualitatively without getting into the quantitative reason why it works. So this is where we're going to now look at a problem, And this is a typical problem that you would a student would have, whether it's physics class, math class, engineering class. So I just pulled this problem from MATHguide's Quizmaster, and I pasted it right there. So let's say we have this object. It's on an inclined plane. Poof. What I would do is I would draw a triangle. Okay, so I already drew one earlier, so I'm just pasting it right there. And let's pretend that we have this object, right? So there's this object, which I'm just going to draw a rectangle, pretending it's a box or something. And this box is exerting a force. Okay, so what I'm going to do is I'm going to use the right side of this to represent 648 pounds. So we have this downward force on an 8-degree angle, and what we want to do is determine what kind of force is really this box pushing down the incline. Okay, so see, some of the force is going to be absorbed by the hill. Okay, now what does that look like? Well, what I mean is this. I'm going to try to draw this as best as possible. Well, that's not too bad. Maybe I could do that a little bit better. So imagine there's this force that's perpendicular to the plane. Okay, this force I don't care about, right? Because that force of the box, or in this case it's just an object, right? That's going to be repelled by an equal and opposite force from the hill. So when the object is pushing down on the hill pushes back. How do I know the hill's pushing back? Because the box doesn't go through the hill. That means the hill must be pushing or exerting some force back up on that object. Okay, so in other words, I don't care about this perpendicular force to the hill. What I want to know is, what's this force that's pushing down the hill, right? So if you put an object on a hill like a marble, right, and it's a smooth hill, it's going to want to roll down the hill. Same thing here. Now, yeah, I know we're not talking about friction, but assuming there was like wheels on this thing, it's going to want to roll down, right? It's going to want to roll down the hill, and I'm trying to figure out what that force is. How much of the 648 pounds is wanting to go down the hill, right? Gravity's trying to pull it down the hill. Okay, well, there's a little bit of math that we're going to do here, right? So, first of all, we've got to figure out what's going on with this diagram. Well, if this is an 8-degree angle right here, okay, so I know that that's an 8-degree angle, I'd like to figure out what are some of the angles inside this diagram. Now, the easiest way, in my opinion, to do this is, remember, this is just a giant right triangle, right? It's a giant right triangle. So, this angle right here at this corner is 90 degrees. So this means this angle right here at the top end should be 82 degrees. Right? It's got to be 82 degrees. Why? Because all three angles have to add up to be 180. So if I've got 82 plus 8, that turns out to be 90. 90 plus this 90-degree angle is going to make 180. Okay, so I know that that top angle has to be 82. Now really I have another right triangle embedded within this diagram. If this is a right angle, right, if these two vectors are at right angles, they're perpendicular, right? One's flowing down the incline, one's perpendicular to the incline. Well, I now want to figure out what this angle is. Now again, those three angles have to have a sum of 180 degrees. So I know that I've got 90 there, so these two angles over here, they have to add up to be 90 degrees also. So this has to be 8 degrees. All right, well, you know, we could run through this kind of mathematics all day long, and we could keep doing these kind of problems, and they would see that the incline, that angle, is always going to have the same angle right here. Okay, and it's always going to be that case. But it's kind of important to show why it is, and I think the 180 kind of really demonstrates that. Okay, so now that we know that that inside angle is always going to match the angle right there of the inclined plane, we can now move on. All right, so let's do a little bit of mathematics. Now I know that I want to find this force right here. Okay, that force. Notice how that force is opposite, right? It's running opposite from the angle. Okay, that means if I'm using opposite, then that's a sine function. So I'm going to take the sine of 8 degrees is going to be opposite, that's the force I'm looking for, divided by the hypotenuse, which is 648. All right, now how do you solve it? Well, you put this over 1. You do a little cross multiplication. It's not that difficult, right? For students in a trigonometry class, they should be able to do this. Cross multiply, you're going to get 648 pounds times the sine of 8 degrees. And I already did this. All right, so I threw this into a calculator, and the calculator spits out, I'm going to look over here, it's 90.184. And of course, this is still the same force, so it's still pounds. And there you go. So this is what the explanation looks like, and that's something that you would want to run through in a class. And you can see it doesn't take that long. It takes about 6, 7, 8 minutes as you go through this. Maybe 8 minutes, because students may have some issues or some questions about the incline, how the angles work, how you get the 82 and the 8, maybe how to solve this, whatever. So you set aside about 8 minutes to do this. Not a long process. So let's talk about the MATHguide Quizmaster. So you could see this is where I got the problem from, and by the way, I'm going to put links in the description of this video. You'll see all the links that are on MATHguide. You could click on them and you could get to them. Okay, so here is the problem that I did get from MATHguide. And you'll notice that I already put in an answer, right? So the answer was 90.184, right? When I hit check solution, I get this red indicator. And of course, this indicator means that there's an error and we've got to try again. And you're thinking, wow, I did all the math correctly. There's got to be a problem with the website. Nope, not a problem with the website. Of course, students often have a problem with the calculator. They have the wrong unit. They're in radians. Okay, it should be in degrees. But anyway, the issue here, well, the directions say to the nearest tenth. So if you round this, and some people even round incorrectly, and they'll get the wrong answer, but if you round it, it should be 0.2. And if they do this correctly, I don't know if you could see it there, but it says, congratulations, try again. That means you're great, right? So the benefit is that when students are doing this, they get feedback. They know if they're doing this correctly, right? You get the red answer. Well, that's the correct answer. But if you get an incorrect answer, like any of those, you know that you're doing something wrong. And also when the teacher is walking around the classroom, when the teacher sees that red indicator, they know that there's an issue and they need to then help a student and dig into the math and maybe point out where that student should do a little bit more work. All right, well, thank you very much for watching. And just remember that MATHguide has hundreds of lessons, quizzes, and instructional videos. Take care and have a great day. Man, I should have used that car in the video. Yeah, earlier. Yeah, I drew that rectangular box. Oof. I like that one, though. Doesn't that look a lot nicer? Yep. Yeah, live and learn. Live and learn.